Alright, today in Advanced Algebra 2 we start out talking about what the discriminant can do for us. Remember, the discriminant is that part underneath the radical in the quadratic formula. It's just a b squared minus 4ac. So we don't have to do the entire quadratic formula. All we got to do is figure out what b squared minus 4ac is. And there's 4 different things it'll tell us in 3 different cases. First of all, if the discriminant is positive, we've got 2 different scenarios here. That's kind of in red. If we do b squared minus 4ac and that gives us a positive number, we know we're going to get 2 types of roots. Now, it depends on what that number is. If that number is a perfect square, so it's positive and it's a perfect square, we'll get 2 rational roots. And if that is a positive number but it's not a perfect square, we're going to get 2 irrational roots, because you got to square root it. It's like once you do the quadratic formula, it's getting square rooted. So we'll realize that here shortly. If the discriminant is actually equal to 0, then you only get 1 rational root, because that thing's only going to cross the x-axis. That parabola will only cross the x-axis 1 time right there. And if the discriminant is negative, that means you're going to get 2 complex roots, because that parabola never crossed the x-axis. Like, it tells us the number of roots that we're going to get in this situation. So in these guys right here, it says let's find the value of the discriminant and then tell the type of roots. So first thing, it's got to be in standard form. So x squared plus 12x. We've got to add 4 over here, get it equal to 0. We need this bad boy in standard form first, and then let's identify a, b, and c. Your paper doesn't have these, but mine does, just to save a little bit of writing. So a is 1, b is 12, and c is 4. I think that's good to realize. And then I personally like to write b squared minus 4ac down, because they want to know the discriminant. And then I'll substitute right underneath that. That would be 144, because that's what b squared is, minus 4 times 1 times c, which is 4. And then I will let my calculator do the rest for me. I just need, come on baby, 144 minus 4 times 1 times 4, and boom, I get a discriminant of 128. Pen, sorry about that. 128. And now I realize what I have going on for me. I've got a positive number, so it is in one of these 2 situations. Since 128 is positive, but it's not a perfect square, that's going to give me 2 irrational roots. Irrational roots, it means like you get those nasty numbers that can't be written as a fraction, like square root of 2, square root of whatever. Square root of 128, that's an irrational number. So let's roll with this guy right here. If we jump over to number 2, he's already in standard form. A is 9. B is negative 6, and C is 1. And now let's find the discriminant. So b squared minus 4ac. That would be 36. Remember, even though b is negative, who cares? You square them and you get a positive. Minus 4 times 9 times c, which is 1. And you could punch that all in. 36 minus 4 times 9 times 1. That'll give you a big honker, 0. If the discriminant is 0, so that's what we'll put in blank A. They say find the discriminant. That means there's only 1 rational root, because that parabola will totally cross the x-axis in one place. Hint, 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 hint. That will always happen when this is a perfect square trinomial. If you notice, the first term's a perfect square, its square root is this. The last term's a perfect square, and you bring the sign down from the middle, and twice the product of those is that negative 6. That's when the discriminant will be 0 every time, is when this guy right here is a perfect square trinomial. So let's just keep on rolling. This guy is in standard form, so A is 4. B is negative 4, and C is 11. I think it's a good idea to write this stuff down off to the side. I don't know. It's not like you have to. It's just less mistakes are made that way. And then b squared minus 4ac is how you find the discriminant. There will be some ACT questions, like what's the value of the discriminant, how many roots are there. So it's just cool to figure this out. That would be 16 minus 4 times 4 11. And let's punch that in. 16 minus 4 times 4 times 11. Boom, negative 160. Since you get a negative discriminant, that's where you're going to get two complex roots. You're going to get imaginary answers. So, two complex roots. That means that parabola would not cross the x-axis at all. So you get two imaginary answers, complex roots. Let's roll with this one. A is 1, B is negative 7, C is 6. Remember, that has to be in standard form first. B squared minus 4AC, so 49 minus 4 times A times C. And we punched all that cool stuff in. 49 minus 4 times 1 times 6. Boom, 25. So since that is a positive number, since the discriminant is greater than 0, I will get two answers. And 25 is a perfect square, so I will get two irrational answers. Remember, this is like part of the quadratic formula, and since you're square rooting this is the number underneath the radical, and since 25 is a perfect square, you're going to get two rational answers. It's going to come out real nice. So, a couple more. This is equal to 0, so it's in standard form. A is 4, B is 20, and C is 29. And let's roll with it. B squared minus 4 times A times C. 400 minus 4 times 4 times 29. 400 minus 4 times 4 times 29. Boom. Negative 64 is my discriminant. And don't get fooled by that. People are like, oh, that's a perfect square. It's negative. So there is two complex answers. Two complex roots in that situation. And then the last one here, we got to get him equal to 0. So that'd be 4x squared minus 4x minus 11 equals 0. A is fair, B is negative fair, C is negative 11, and so we get ourselves B squared minus 4 times A times C, 16 minus 4 times 4 times negative 11. Out of the way, calculator. Times 4 times negative 11. Boom. 192, which is not a perfect square, but it is positive, so that's two irrational roots. So, pretty simple, man. Just kind of memorize this situation right here of what's rolling on with you, and we can continue.
Advanced Algebra 2, today we'll write quadratic equations in vertex form. We know standard form, we're pretty familiar with that, y equals ax squared plus bx plus c. What we did last year was we transformed from standard form into vertex form by completing the square, which is the way it's like originally supposed to be done. It's a giant waste of time to complete the square, to put it in vertex form, because we have better knowledge of how to find the vertex and what the a value is. So we're not going to complete the square. So please note, if you see any instructions on homework or something that says put this in vertex form by completing the square, you do not need to complete the square on it. Please do it the way I show you today of how to put it in vertex form. So many of you have seen this before. Vertex form, y equals a times the quantity of x minus h squared plus k. Make a note that the vertex is at the ordered pair hk. That's why it's called vertex form of a parabola. The point hk is the vertex. To where, if we think back to our purple note card, you know, the 4 steps on it, we could purple note card this guy. They want to know how this thing would open. So you look at this number and what would happen for openness. Why would that thing open up? A has to be positive, and it would open down if A was negative. That's step one, openness, if it gets reflected over the x-axis or not. It's all about a value. 2, if it's in vertex form, the translation will be hk, because isn't it the opposite of this guy, which it says negative h, right? So that would be positive h. So it moves left or right this amount, and then up or down, what you see is what you get with k, right? 3, the dilation is about the a value again. Forget about his sign. Just think of him as positive. It says think about the absolute value. If it's bigger than 1, does it get vertically stretched or vertically compressed if that number is bigger than 1? Vertically stretched. And what happens when you take a parabola and vertically stretch it? Does it get fatter or skinnier? It gets skinnier. And if that number was between 0 and 1, it would get vertically compressed, which means it gets fatter. What if it was 1? There'd be no dilation whatsoever. And then reflect over the x-axis. It's not going to happen if it's in vertex form, because this number has to be something other than 1. Reflect over the y-axis. Not going to happen if it's in vertex form, because this number always has to be 1 for that to be in vertex form. So they say write this in vertex form. Here is that formula again. You have it right at the top. You need 3 ingredients. You need to know A, you need to know H, and you need to know K. Correct? A is the easiest one because they gave it to you in standard form. Do you know the A value already? What's A? A is 2. So make a note. A is 2. I need to find H, which is the x value of the vertex. This is why we want to do it a different way, because students don't know how to find the x value of the vertex as well as we want them to know. You've done it many times before. Let's do this. H equals the opposite of b over 2 times a. Remember doing that? Find the x value of the vertex, opposite of b over 2 times a. This has to be in standard form for that to work, which it is in standard form. So what's the opposite of b? 12, 2 times a, 4, isn't the x value of the vertex, which is the h value, correct? Doesn't he turn out to be 3? Now how do I find k, which is the y value of the vertex? If you know an x value, how do you find a y value? Substitute that puppy in. So grab your calculator and substitute in where you see an x, put a 3. Just type that puppy from left to right. You're going to type 2 times, go for it. I'm not going to do it for you. Tired of babying you. If you need a calculator, come grab one. What'd you get? 1. So now let's write that in vertex form. So that would be y equals a, how much was a, baby? 2, times the quantity of x minus h squared plus k. That is 1,000,000 times easier than completing the square on that thing, because we have been doing this part for years. You learned that in Algebra 1. Find the x value of the vertex. Once you have the x value substituted in, find the y value of the vertex. And a, duh, it's right there, right? It's 2. So there we go. What's the vertex then, baby? What is the vertex? 3, 1. Let's graph it first and then talk about the axis of symmetry. So I don't want to use my graphing calculator. I might not let you use it on your graphing calculator on these. Let's make a table of values. That's what vertex form is all about. The table of values, the vertex form is easy to graph because, duh, you know the vertex already. Isn't it at 3, 1? Right? Put that in the middle. Pick 3 points bigger than this. How about 5? And 3 points smaller. Do you have to do all 6 of those points, really? Yes or no? Isn't there symmetry around that axis, or around the vertex? So let's put probably these in. These would be better for us. All I got to do is put 4 in for x. We can do it mentally. right? That's what vertex form is all about. If you put 4 in for x, you'd have to do 4 minus 3. What's 4 minus 3? 1. Square it. 1 times 2. Add 1 to it. Boom. 3. Then isn't he also going to be 3 right there? Correct? Let's put 5 in. 5 minus 3 is 2 squared times 2. Add 1. 9 and 9. Now do 6. Put 6 in. Did you get 19 back? Takes a little bit. 6 minus 3 is 3. Squared is 9. 18. 19. And obviously we won't be able to graph that with this grid, but now let's graph. Plot the vertex first. 3, 1. You tell me, first of all, how should this thing open, up or down? Should open up, right? And 4, 3, meow, meow, meow. And 5, 9. That's all I got. Connect together. La, la, la. You will need a straight edge, so if you got one, get it out real quick. Otherwise, I'll pass them out. This is the parabola. They don't really ask us to graph the axis of symmetry. Let's graph the axis of symmetry as a dashed line. By now, I hope you know the axis of symmetry is a vertical line. Isn't this parabola symmetrical right through that vertex right there? What does the equation of any vertical line look like? How many variables are in it? Just one. Which one? X equals. What does x equal? It's the vertex. What does x equal? 3. So the axis of symmetry is not 3. It's x equals 3. It's the line, x equals 3. Direction of opening was what? Up. Let's talk about another question that threw a lot of people for a loop last year. They don't tell you to do any of this stuff. They just give you this. Say, find the minimum slash maximum. Find the minimum slash maximum. The reason why is because it depends on which way that thing's opens. If it opens up, doesn't that have a minimum? Right? If it opens down, doesn't it have a maximum? Where is that point at every single time? What's that called? The vertex. Right? When they ask you to find the minimum or maximum of this, find the vertex. X value, Y value. Cool? H, K. Let's do it again. You'll see at the top, I believe the instructions say, put that in vertex form by completing the square. No dice. We will not complete the square on it. We will use the cool formula. We need 3 things, A, H, and K. What does A equal in this guy? First of all, that has to be in standard form, which it is in standard form. What's the A value? 1. Right here, right in front of it. That's the A value. H is the X value of the vertex. You find that by opposite of B over 2 times A. I think the more times you write that formula, the easier it is for you to remember what to do. Right? Opposite of B over 2 times A. That's why I like to write it. Which would be 8 over 2, which is 4. That's the X value of the vertex. We call him H. Cool? How do you find the Y value of the vertex, which we also call K? What do I need to do? Substitute that puppy in. So grab UNS calculator and sub in. Make sure you're substituting in with parentheses. That makes a huge difference on many things. Put in 4 in for X, and that will tell you what Y equals. K equals -10. All right, so let's put this in vertex form. Remember, that formula is this again. So what should I write? Y equals. Do I really need to put the 1 there? Don't put the 1. X plus 10 minus 10 plus 4 minus 4. Minus 4. Don't forget to square that quantity. That's the biggest mistake. Oops, forgot the little squared. Then plus 10 or minus 10? Yep. Cool. Let's make a little table to graph this puppy. Throw the vertex in the center. Nice. Then 3 numbers bigger. Be careful with that. And 3 numbers smaller. Try it again. It doesn't matter which 3 you choose, you know. You just got to put them in here. 4 is positive because that was going to cause me a major problem. Sorry. Thank you for correcting me. 4, 5, 6, 7, 3, 2, 1. We were going to get some mega numbers. I was like, this ain't going to be right, you know. We cool with that? So 4 is the x value of the vertex. Thanks for the correcting. Put 5 in. 5 minus 4 is 1. Square it, you get 1. 1 minus 10 is negative 9. Continue. Fill out the rest of that table for me. I would substitute these numbers in personally. Did you get to what I got? Go negative 9, negative 6, negative 1 down the line. Plot them, graph them. I like to plot the vertex first. 4, negative 10. 5, negative 9. 6, negative 6. And 7, negative 1. If they don't ask for the axis of symmetry, then don't graph the axis of symmetry. But if they ask for it, graph it. But they don't. Double check, he should open up, which he does. Where's the minimum point? I would actually, you know, that's interesting. People say, is it just negative 10 or is it negative 4, negative 10? The right answer is negative 10 is the minimum. You know, it's the y value of the vertex. But I wouldn't mark it wrong if you put negative 4, negative 10 as the actual vertex. It depends on how they word the question. You know, like where's the minimum point? You know, or what's the minimum? You know, so difference between those. Yep. Is that in standard form? Yep. Let's put them in vertex form. First, I need A. What's A? Negative 4. H is the opposite of B over 2 times A. Two, right? And then I'll let you substitute 2 in for x to find the y value of the vertex, which we also call him K. Cool. So y equals negative 4 times the quantity of x minus 2 squared plus 5. Correct? Table them up. Of course, if you do have a graphing calculator, you can use the table of values, but we need to practice our mental skills. By putting these numbers in, you kind of get positive numbers most of the time out of that situation. If these are positive, those will be positive. That'll work out nice for you. So if you put 3 in, you get a 1 here. Squared is still 1. Negative 4 plus 5 is 1. 2, 4, negative 8 plus 5, negative 3, negative 3, 9, negative 36 plus 5, negative, whoa, wait a minute, 5 minus 2, 3, right? Squared is 9 times negative 4 is negative 36, right? Plus 5, negative 31, is that right? Was this right for this guy? Negative 3. 4, negative 16 plus 5, that sure wasn't right. Yeah, that wasn't right. You can't jump that much. negative 11, because you get 4, negative 16 plus 5 is negative 11. How bad? Negative 31. Where did this go? That's 1. That's negative 11. Plot them. 2, 5. 3, 1. 3, 1. 4, negative 11. I will just kind of take a rough guess, since that's just 1 off the grid. No big deal. Holy smokes, that's a skinny parabola. Man, that's skinny. Why is he so skinny compared to the other ones? What's so skinny? He runs a lot. Tell me, why so skinny? A value, right here, if you think of him as an absolute value, is 4, and that got vertically stretched by a factor of 4, 4 times skinnier. Sweet! Just for fun, no thanks. That was when we needed to complete the square. I think we get the idea, right? All right. If a vertex and one additional point of a parabola are known, you can write the equation in vertex form. A lot of you have done this before. Here's the graph. Do you know the vertex? Yes or no? Put him, right? Vertex and point. The vertex is at 3, 2. They should give you some other point on that parabola, which, as you can see, here's a point at negative 1, negative 2. Writing those down makes a big difference. And then the next thing, if you do this, I've done this for quite a few years now, if students do this next thing, they will have a lot of success. The vertex, isn't that HK? Put an H, put a K above those 2 points. This point, since it's not the vertex, aren't points written as X, Y also, correct? They want us to write the equation of this in vertex form. Here's vertex form. Write this down. You will write the formula down first. You will write the formula down first. You will write the generic formula down first. They want it in vertex form. There are 5 ingredients to this. Y, A, X, H, and K. 5 ingredients. I've got H, I've got K, I've got X, and I've got Y. What's the only thing that I don't have? I don't have A. So let's, right below this, that's why we write the formula down first, let's substitute in everything we know. Y is negative 2. Correct? A, I do not know. X is negative 1. H, 3. So I got minus 3. That's got to get squared. And K is 2. I took all 4 of these ingredients, put them in this formula. The hardest part for y'all is following the order of operations. Let me do this wrong for you. This is what most students do wrong. Negative 2 equals, they do this, isn't negative 1 minus 3, negative 4. Square it, you get 16. They got this then. They write 18A. I don't know why they do that, but here's what they're doing in their head. A times 16 plus 2. They decide that they should add the 16 and the 2 together. Can you add the 16 and the 2 together when 16 needs to get multiplied by A first? Can you do addition over multiplication? So be very, very careful. Here's what you do. You figured this out. Negative 4 squared is 16. You put him first, then you put the A next to it. Because we don't write A16, don't we write 16A? Plus 2 is still there. Our job, solve for A. What would I do to solve for A? Yep, be very careful. All right, that's not 0. That would give you negative 4. Then you should divide by 16, right? So don't get brain farted. It's really this, right? Which is not negative 4. What does that reduce to? Negative 1/4 is what A is. You are not done, but before you finish this, I want to see if this makes perfect sense to you. Should A be a negative number when you look at that graph? Should A be a negative number? That thing's open and down. So now let's write the equation of this guy in vertex form. I need A, H, and K. Don't I have A, H, and K? So y equals negative 1/4 times the quantity of x minus 3 squared plus 2. You substitute back in A, H, and K and call that your answer. On the next guy, they give you a graph, write down the vertex and the point. Vertex. Once you have those written down, H, K, X, Y, don't assume it always goes in that order. You know, the vertex is H, K. The point is X, Y. Start with the generic formula every time. That helps you memorize it. Then substitute the 4 ingredients in that you know. Tell me about A before we even do this. Will it be a positive number or a negative number? It better be positive. That thing's opening up. Subbing in. X is negative 4. H is a minus 1, so I have a minus 1 in there. Turns into a plus 1. Negative 4 plus 1, negative 3. Squared is 9. Stick that A with him. Then got to add 2 to both sides. 15 equals 9A. Divide by 9, A equals 15 ninths, which can reduce. What does 15 ninths reduce to? 5/3. Positive number. Check. Right? They very likely will come out to be fractions and all kinds of crazy stuff. Not finished. Y equals 5/3 times the quantity x plus 1 squared minus 2. Putting them back in vertex form. A simple ACT question. Would they give you an equation in vertex form and they say, what's the vertex of this parabola? If you've never seen vertex form before, that'd be a hard question to answer. But you know the vertex is -1, -2. One more. No more graph, right? They give you the 2 points, though. One of them better be the vertex. One of them be a point. Which one's the vertex? So H and K, X and Y. Last one of these, baby. Get her done. Please pause the video. Give this puppy a shot. Start with the generic formula first. You check yourself here. It turned out that the A value turned out to be -15. You don't even need to put the +0 right there. And then you substitute back in. This is the forgotten part. You forget. People get satisfied because they found that. Here, next one.